this is a review of limits, very basic sort of review, hopefully not anything that is too scary for those of you who might need some recap and re-explanation. The first thing I'd like to mention actually is a video link. This is something that I would recommend that you take a look at. It's by, I think the guy's name is M. Michael Kelly, and he does a very nice job here at this website. He has a number of links, but the first few about what is a limit, I think there are 6 of them listed underneath the topic of a limit, but I'd recommend watching maybe the first 4, maybe all 6, but the first 4 are very nice, give you a nice solid foundation and a good metaphor for what limits are, okay? If you take a look at the problems that I have for you here, basically this series of problems is to connect the visual with the idea of what a limit is, and to remind you of a little notation, and also to emphasize the fact that a function can take on values that are different from the limit at certain times, okay? So let's take a look at each of these. The first block of questions here all have to do with the value of 2 relative to this particular graph. So I'm understanding these boxes to be by 1, so this is the x value of 2. Limits ask for what the function is doing, what the y value is doing, as x does blah, 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 fill in the blank, okay? And the x approaching whatever, that's the filling in the blank of what x is doing. So limits are asking us this. Limits say, as x does whatever, it's asking you what is y doing, or what is f of x doing. Apparently I can't spell today. Doing. Okay, that's the question that a limit is asking us. Okay, so this is saying what is y doing as x approaches 2 from the right. So here's 2, and I want to get closer to 2 coming from the right. So it's all of those blue dots marching over to 2. What is y getting closer and closer to as I come along here? Well, y is 2, and then it's 2.1, and then 2.8, and then it's 3, and then 3.1, and then 3.5. You can see that these y values, which correspond to this part of the y-axis, are getting closer and closer to 4. Okay? This part is asking, again, as x gets closer to 2 from the left, what is y getting closer to? All right, well, now I'm coming up this way. And as I get closer and closer to that value of 2 for x, what's happening to the y values? Well, they're getting closer and closer to 4. Now, when the right hand and the left hand limits agree, then we have an overall limit. Our overall limit here is 4. However, look at what f of 2 is. F of 2 means you put 2 into the function, what do you get out? Well, I see here that there's a hole. So this function value does not exist. That's the abbreviation for does not exist. So even though the limit exists, the function value does not exist. This function is discontinuous at 2, okay? There's a hole in the function. All right, the next part. This block of information is asking us about the same function, but looking towards the x value of 4. So I'm going to erase up this part, and let us start again, okay? First question is, as x approaches 4 from the right, here's 4. Coming from the right, I am staying steady at a y value of 1. Coming from the left, marching along, okay? I am getting lower and lower and lower y values, getting closer and closer to 2. Now, sometimes people will ask me, well, what about out here and over here? Well, that's not really getting closer to 4, approaching 4. That's like saying your birthday's coming up in April when it's August now, okay? That's not really close, okay? If you have something that's, you know, coming up, that would be something like Labor Day is coming up, or Spirit Week is coming up. Those things are close. This is not really what we would call close out here, okay? Close to 4 is in this region of our graph, okay? And it's not a particularly firm definition, the close idea, but close, okay? If you ever take a real analysis class, then you'll explore what we mean by close, okay? X approaches 4 overall. Well, do these match? No, they do not. So this limit this overall limit does not exist, even though the right hand and the left hand limits do. How about the function value at 4? Well, I go here to 4. There is a function value at 4. It's this colored in dot. This is a hole. That's not a point. That is the absence of a point. This is 2. Okay? So understand that things don't necessarily have to match up all the time. Sometimes they do, but sometimes they do not. Okay? I would like you to pause the recording right here and try these problems. And then when you start the recording again, poof, all of the answers will be here. Okay? Hit pause now. Try them on your own. Okie dokie. So hopefully this is what your paper looks like. Hopefully just like this, neater handwriting. You can see that for the ones that are around 0, the limits turn out to be 1. 1, 1, 1 all the time. But the value of the function doesn't exist. That is because there is a hole right here, and that is not a point. It's an absence of a point. Okay, over here, this is something sort of interesting. It also points out one of my pet peeves. Limits, by definition, are finite amounts. And so if we can see here that from the left, our function is going to go bigger, 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 and from the right, our function is getting smaller, 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 these limits do not exist. However, we sometimes will describe why the limit does not exist. And we write symbols like this. We write the symbol here, negative infinity, because coming from the right, this function is going lower, lower, lower. Okay, going huge, but in the negative direction. And so that's why there's a negative sign here. This second answer indicates this behavior. Our function is getting bigger, 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 going positive forever. Okay? And so these two things are what I would call descriptive limits, which is a bad name because it's really descriptive non-limits. Okay, it's describing why the limit doesn't exist. Okay, so don't get too confused on that. Limits, by definition, are finite. These are infinite, right? Therefore, they're really just describing why the limit doesn't exist. So indeed, the overall limit doesn't exist, and the function value at 4 doesn't exist because at 4 we have a vertical asymptote. That is a type of discontinuity. Another type of discontinuity we saw here, a hole. And another type of discontinuity we actually saw back here. This is what we would call a jump discontinuity. Okay? And interesting things happen when there's discontinuities, okay? Once again, I'd like you to pause this and in a few seconds restart and see if you got your answers right. Okay, ta-da, here are your answers, I hope. You can see that for 3, you get that the function is going this way towards 3 from the right, getting closer to 0, going this way towards 3 from the left, getting closer to 1. These two values are different, so the overall limit doesn't exist. And the point at 3 is right here, and that value is 0, okay? The circle, it's the absence of a point. All right, for the part about 6, coming from the right and from the left here, you are approaching the value of 3, which means the overall limit is 3 because these two things match. However, the function value doesn't exist. This point here is a hole. I shouldn't have even said point. That is a non-point. That is a hole. So right here, 6, 1 is the point of interest that tells us the function's value at 6 is 1. All right, I hope this has been helpful to you. If you're still feeling a little at loose ends about limits, feel free to watch this. Of course, also ask me for help in class or for additional materials if you're having a hard time with limits.